Hello friends, in this video I am going to teach you about EPlane Tee in microwave T junctions. We know microwave T junctions are used to split the microwave power into different directions. Among them, one of the T is EPlane Tee. This EPlane Tee is also used to split the microwave power into two different directions with phase shift of 180 degrees. First, let's see what is the difference between the normal rectangular waveguide and the E-plane Tee and how we can construct the E-plane Tee from normal rectangular waveguide. Let's see rectangular waveguide. It is rectangular waveguide. We know already rectangular waveguide is having the two ports, that is it is a port 1 and it is port 1, port 2. Okay. Now observe here 2 points, that is here every rectangular waveguide is having two borders, that is this broader dimension and narrow dimension. Let's observe here, this is the red color mark is broader dimension of rectangular waveguide, and yellow color mark is narrow dimension of rectangular waveguide. If we connect one more port to the broader dimension of the rectangular waveguide, then we call that type of T is E-plane T. And if we connect one more port to the narrow dimension of the rectangular waveguide, then we call that as a H-plane T. In this video, I am going to teach you about E-plane T. So, we need to connect one more port to the broader dimension of the rectangular waveguide. Broader dimension is nothing but this dimension. Okay. We need to connect one more port. Then the E-plane T will become like this. Okay. This is the E-plane T. This is the broader dimension and we are connected one more port to the broader dimension of the rectangular waveguide. Now total we have three ports in E-plane T. That is, this is the port 1 and this is the port 2 and the top one is port 3. Now I am going to define E-plane T. That is, let's see here, attaching a simple waveguide to the broader dimension of the rectangular waveguide which already has two ports, then the T is called E-plane T. I already told you, if we take one simple rectangular waveguide and attach one more waveguide to the broader dimension of the rectangular waveguide, then it will become like a E-plane T. And as the axis of side arm is parallel to the electric field, this junction is called E-plane T junction. This is also called as voltage or series junction, which means here we know the electromagnetic waves or the microwaves are transmitting through these waveguides, and we know in microwaves we have both electric field and magnetic field. Here the electric field is parallel to the port which is connected to the broader dimension. Okay, here already mentioned, as the axis of the side arm is parallel to the electric field, this junction is called E-plane T junction. Okay, and this E-plane T is also known as voltage or series junction. Here observe pictorial representation, then we can understand very much clear. Here it is the port 1 and it is port 2 and the top one is port 3. Here observe, the port 3 is connected to the broader dimensions of the main waveguide. This is main waveguide and this is the auxiliary waveguide. The top one is auxiliary waveguide and the bottom one is main waveguide. This auxiliary waveguide is connected to the broader dimensions of the main waveguide. Then we call this type of T is E-plane T or voltage or series junction. Here observe, it is a electric field direction. Here observe arrow mark. This arrow mark indicates electric field direction. We know electric field direction is always indicated vertically and magnetic field direction is always indicated horizontally. Whenever this electric field direction is in the case of vertical, then this port 3 is also parallel to this electric field. That's why I mentioned here the port 3, that is auxiliary port, is parallel to the axis of the electric field. Okay, and this is about the definition of E-plane T. Now let's see the operation of E-plane T. Okay, the outputs we get in this type of T are 180 degrees out of phase with each other irrespective of form which output the input is fed, which means whenever we give to the input of to the input to the any port of the E-plane T, then the output should be 180 degrees out of phase. Okay, and if the input signal is fed to the port 3, let us assume if you give input to the port 3 of EPlane Tee, then the output will be split across port 1 and port 2 and will be 180 degrees out of phase with each other. That means whenever you give the input to the port 3, then that port 3 input is split between the port 1 and port 2 with the 180 degrees out of phase. Since the electric field lines change their direction when they comes out of port 1 and port 2, it is called E-plane T. That means whenever you give the input to any port, any one port of the E-plane T, then that input is delivered to the output of both ports with 180 degrees out of phase. Let's see, this is in pictorial representation. It is port 3 and it is port 1 and it is port 2. If we give input at port 3, if we give input at port 3, then it is split between the port 1 and port 2 with 180 degrees out of phase. That means here observe, this arrow mark is upwards and this arrow mark is downwards, which means 180 degrees out of phase between the port 1 and port 2 when we apply the input at port 3. And this is about the operation of E-plane microwave T junction. I hope you understood this topic. Thank you for watching this video.